Hello everyone, can you all please confirm in the chat box if I'm audible to all of you? Can you please write in the chat if I'm audible? Kindly confirm in the chat if I'm clearly audible to all of you. Please confirm in the chat so that we can begin with the class. Okay, thank you Vidhi for the confirmation. Others, can you all also please let me know if I'm clearly audible to all of you, and the screen, I hope it's visible. Um, Okay, thank you, Monish, also for your confirmation. So, yes, students, welcome back to Tuition Masters, and this is your master teacher, Ria. And today we are here with our another video for grade 9 maths, that is number system and polynomials. So number system plus polynomials, these two chapters we are going to do a very quick revision, as well as we are going to play two Menti quizzes today. First will be for number system, second will be for polynomials. So in this session we are going to cover these two chapters. We'll quickly revise all of them, all the important things. We'll do few subjective questions and even do the Menti quizzes. After the completion of the one number system theories, then we will do the Menti quiz for number system. So let's start with our first thing. So remember students to like, share and subscribe. If you didn't like it yet, like the video right now. Share it with the other friends so that when we play the Menti quiz, it's more fun when all your friends are here. And subscribe to the channel if you didn't do it till now. So let's start with the first chapter, that is number system. Right, so number system, quite a basic chapter. As the name says, number system, we learn about the different properties of numbers, what are different types of numbers and everything. So see, first part is that itself, what are the types of numbers. So basically when you might be in the previous grades, you might have studied natural number, whole numbers, integers, right? But there are more types of numbers. So when I say first one is natural number, natural number are nothing but my counting numbers. Counting numbers means whenever you count from like whenever you count, so what you do, you always start from one, right? Like 1 2 3 4 5 6, that way. So these counting numbers which start from 1 are known as natural numbers. How do I denote them? I denote them by a n, a capital N, and it starts from number 1. Okay, that are my natural numbers. Next one, whole numbers. Whole numbers are what? Whole numbers means that nothing, no difference, only natural numbers, and I will put a zero in the starting. So I have 1, 2, 3, 4, and it keeps on going. This becomes a natural number. Now when I put the 0 in the front, so this becomes my whole numbers. How do I write whole numbers? It is symbolized by a capital W. Okay, a W is represented as a whole number. Next are integers. Integer means the three types of numbers. When I have natural numbers also, I have a 0 and negative numbers also. So those are my integers. Now how do we write it? We write it in a Z. We write Z. So that is equals to what? You will start with the negative numbers, -2, then -1. After that comes 0. Then after 0, 1, 2, 3. It keeps on going till infinity and negative infinity. So integers are that, that is why it is the negative plus positive plus 0. Now can you guys tell me in the chat box, why do we write Z for integers? Why don't we write I? Why I is not written? Why is it integers is written in Z? Because Z is nowhere found in the integer. So why do we write Z still? Correct. Can you tell me in the chat box, why is it so? Is there any specific reason? Why do we write Z instead of I or some other alphabet? Why Z? Because natural numbers we write N. Whole numbers we write W, the starting letters. Then similarly for integers, why don't I write I? Why is it Z? Can you guys tell me in the chat box? Why is it so? What's the reason behind it? Yes, you can tell me in the chat box. I'm waiting for your answers. Or should I tell? You guys know the answer. What is it? Okay, Mohini says you don't know. Okay, what about Vidhi? What do you think? Vidhi, do you know about it? Why do we say, write? We write integers with denoted by Z. Why is it so? So basically, Z, we read it, Z means it came from an Urdu word, that is known as Zehlan. Okay, Zehlan. From this word, what happens? This is known as some, numbers. Numbers are some, I can't recall it properly, but yeah, Zehlan, it's that number. In Urdu, it is called as numbers or negative numbers, somewhat like that. So that is why we take the Z out of it. So that is why integers are written in the form of Z. That is the reason. Now, minus 1, minus 2, all of these are known as negative integers. 1, 2, 3 are known as positive integers or non-negative integers, common thing. And 0 is in the middle of your number line. Next types of numbers are rational numbers. Rational means that the numbers which can be written in the form of p by q, means in a fractional form. Okay, but there are two conditions. That q, this denominator, should not be equals to 0. Condition number 1. And p and q, they should belong to Z. That is, Z means they should belong to integers. Okay, so when I say P and Q are these two numbers, they should be integers. Okay, and this sign, this E kind of sign is nothing but belongs to sign. Means P and Q, that set belongs to integers. Next is irrational numbers. Irrational numbers are nothing but the numbers which cannot be written in the form of P by Q. And Q is not equals to 0. Alright, the denominator again should not be equal to 0 and they will belong to Z. But the thing is, P and Q, this irrational numbers cannot be written in that form. Okay, the Q will not be equal to 0, P and Q will belong to integers, but still, P and Q cannot be written in that form. So can you tell me a rational number? Such rational number. Can you give me an example of rational number in the chat box? What can it be? Tell me in the chat what can be a rational number. Sorry, irrational number. I'm really sorry. Irrational number, which cannot be written in the form of P by Q. Can you tell me that? What would be such an example of it? The main keyword is cannot. Right, that is the main keyword. You can see even in the poll I gave you, which of these is irrational number. So if you see the first one, 1.41414222, and it keeps on going on. Now there is no end to it. Right, there is no end to it. It's keep on going, keep on going. So we cannot find a proper fractional form for it. So that's why we say that it is an irrational number. Next come real numbers. Real numbers are the collection of rational number, irrational number. Okay, and they are denoted by an R. Okay, so basically, real numbers, when I talk about real numbers, means I'm talking about rational as well as irrational. Rational plus irrational numbers give me a whole combination of real numbers. Okay, now when I talk about real numbers, they have decimal expansions. What they have? They have decimal expansion. Means when I convert it into decimal, they will give me a termination. So what is that? So when the decimal expansion of a rational number, when I talk about a rational number, what will it be? It will be terminating or non-terminating. Okay, terminating means it will have some specific, it will have like, specific number of digits, like 7.1, 7.14, let's take. That's, no, it will be finite number. Non-terminating means like 7.14219, it keeps on going that way. So that is non-terminating. And moreover, a number whose decimal expansion is terminating or non-terminating recurring is rational. Now, when I have non-terminating like 7.14141414, so only 1414 is repeating. So that becomes a rational number, that is non-terminating recurring, because it is keep on going, it's infinitely going, but I can write it in the form of 7.14 bar. That is my recurring. Second type is of irrational. When I talk about irrational numbers, the decimal expansion is non-terminating. Means it will keep on going. It is non-recurring, non-terminating and non-recurring. Why? Because it's non-terminating, because it will keep on going and it will not be any pattern. like 92.78279316 keeps on going on. Random number and it keeps on going on. Can you give me such an example as I asked? Any example of an irrational number? Can you tell me? Any irrational number in the chat box. It can be any symbol. There is a symbol also which is irrational. We use it in the circumference, area, volume of a sphere and circle. What is that thing? That is also irrational. Correct. And even the next thing, any irrational number that will be the decimal of it should be terminating and non-terminating and non-recurring. What will be an example of that? So, any ideas what will be the example? You guys can write it in the chat box. Yes, you can tell me. So, so basically it should be an irrational number. So the quality of a irrational is it should be non. There will be two nons here. One non terminating, second non recurring. So it will keep on repeating. That is non terminating, and it will have no pattern in the decimal expansion. It will be like no pattern. It will be random numbers, right? So the best example for this is pi. Okay, it is pi. Pi, it is 3.14. It keeps on going on, right? But we write it in the form of 22 by 7. That is a rational number. But this 22 by 7 is just an approximation to pi. It is not the exact value. That's just an approximation. So that is why irrational numbers are always non-terminating and non-recurring. Alright, now let's move towards the operations on real numbers. So, based on operations, what can we do with real numbers? So, real numbers they satisfy commutative, associative, distributive properties. These are properties are applicable for addition and multiplication. Okay, now rational numbers are closed with respect to addition, subtraction, multiplication, and division. That means when I add, subtract, divide, multiply a rational numbers, I'll always get a rational number. So that is what it means. Secondly, irrational numbers. When I talk about irrational number, commutative, associative, distributive, it is there. But some difference, quotient, and product of two irrational numbers may not always be irrational. For example, if I say root 2 into root 3, what will it be? It will not be a rational, it will be irrational, isn't it? But when I do root 4, okay, no, root 4, no, it's all obviously a root number. So here let's take root 5. If I say root 5 into root 5, so these both are irrational. But when I multiply them, when I do the product, what do I get? I get root 5 square. Now, whenever there's a square, root and square gets cancelled, so I'll get 5. That is rational. So it's not necessary that always the operational irrational will give me irrational. It can be a rational number also. Now, next thing is here, if you see root 7 plus minus root 7, so it becomes minus. So root 7 minus root 7, what is that? That gives me a 0, isn't it? That gives me a 0. Similarly, root 8 minus root 8 gives a 0 again, right? It gives me a 0. That is also rational. Root 5 into root 5, as I gave the example, root gets cancelled, it is again a rational number. Root 2 divided by root 2. We are doing addition, subtraction, multiplication, division. So I am getting again a rational number. So when you take two same rational numbers, this is what you get. Now let's say that there is a rational number r. Okay, in any rational number, and k is any irrational number. Okay, so when I do r plus k, rational plus irrational, and rational minus irrational, that will be a irrational number. Okay, and rational number divided by an irrational number divided by irrational, what will be that? That will also be irrational only. And rational plus irrational or rational minus irrational gives again irrational only. So What are the standard identities? We should know that there are few identities which are put for easily finding out these calculations for real numbers. So root AB means when I have two numbers in multiplication or write two numbers in multiplication, they can be written as root A multiplied by root B. Next is root A by B. Root A by B is equals to root A by root B. Now this is nothing to explain. You don't have to prove it. You just have to always memorize it. Root A plus root B whole multiplied by root A minus root B. So root gets cancelled. I always get A minus B. A plus root B, A minus root B gives me A square minus B because root again gets cancelled. Now root A plus root B multiplied by root C plus root D. What will happen? Roots will not get cancelled out. I'll get root AC plus root AD plus root BC plus root BD. So we will match with this like this, like this, like this, like this. We are going to match it. And root A plus root B whole square gives me A plus 2 times of root AB plus B. That is nothing but the identity A plus B whole square. That is A square plus 2AB plus B square. So A square means root A whole square. That is nothing but A. And plus 2 times of root A, 2 times of root B. So 2 times of root AB. And plus root B whole square, that is B only. Now, rationalization of denominator. Now, students, whenever we have any like any number, real number, right, for example, root a plus b, like this, which is given. Now, the denominator is irrational. So, if I have to convert it into a rational number, that is what rationalization means. So, what I have to do is that I have to multiply and even divide a number by root a minus b and divided by root a minus b. Why minus? Because let me change this color. Yes, because if here this is positive, so here in the factor I am going to change the sign. So that is what the rationalization actually means. So let's say an example of 1 by I'll change the size 1 by root 2 minus 3. Now how will I do this? I have to multiply by root 2 plus 3. I'll change the sign, divided by root 2 plus 3, the same number. I have to multiply with the same rationalization factor. Now when I do this, what will I get? Root 2 minus 3 into root 2 plus 3. Is it in the form of a plus b multiplied by a minus b? It is in that form, right? So I'm not having space here. I'll just erase this. Yes. So it's in the form of a plus b multiplied by a minus b. That is what an identity is. Which identity? A square minus b square. It is a plus b, a minus b, isn't it? So if I do that way, so what will I get here? I'll do root 2 whole square, root 2 whole square minus 3 square, correct? 3 square. So what do I get? Here it will be 2 minus 9. So what is 2 minus 9? 2 minus 9 is nothing but minus 7, right? Minus 7. So what do I get in the denominator? I'll get it as minus 1 by 7. I take the minus and above. So that, okay, not minus 1. I have to multiply this also with here. So I'll get the answer as root root 2 root 2 plus 3 by 7 minus root 2 by 3 by 7. So what happens? I have rationalized the denominator. It becomes a rational number. Alright. Now let us see the laws of exponents, the last part of the chapter. Now, what are the laws of exponent? For laws of exponent, we are taking A, P, Q here and B also. So, A is greater than 0, any real number, B is also the same, any real number, they are not equal. P and Q are rational numbers. If P and Q are rational number, it can be fraction also. So, how can I frame? A raised to P into A raised to Q will give me A raised to P plus Q, means the when I have the base same, the exponents will be multiplied. Okay, exponents, the power will get multiplied. Similarly, a raised to p whole raised to q, When I have a power, above the power again I have one more power. So the powers will get multiplied. Secondly, a raised to p divided by a raised to q. Now division is happening. The base a is same, so power will get subtracted over here. Now a raised to p multiplied by b raised to p. So powers are same here. So what I'll do, I'll take power in common and write the base as ab multiplied by like a into b whole raised to p. Now a raised to minus p is nothing but the reciprocal, that is 1 by a raised to p. Okay, now for example, if I have 1 by 5 raised to 3, I can write it as 5 raised to minus 3 also, and vice versa. Now, if I have a fraction, a raised to p by q, that's a fraction, so that will be equal to a raised to p by 1 by q. Okay, and equals to a raised to 1 by q by p. So this is how you solve a fraction exponent. And at the end, if I have a plus b and there's a whole power l, or no, I'll take x. So what you have to do, you have to multiply a by x also and b and x also. That is the standard laws of exponent. Now students, let's do some important subjective question and then we'll move towards the Menti quiz. Alright, so are there any doubts? Are there any doubts? Please tell me in the chat box if there are any doubts in this part of number system. Any problem is there? Please tell me. Inter okay, Monish. Okay, anything you want I should repeat again? If it is, you can tell me. I'll repeat it. If any problem you have, you can tell me. I'll repeat it again. All right. We did law exponents. We did right, isn't it? Exponents we did, and we did the rationalization also. If you have any doubts, you can ask me. I'll explain it again. All right. So, oh sorry. Yes, we will. We are going towards the next part, which is uh, the next part, that is important subjective questions. 1 minute. So basically, when I talk about the important subjective questions, so we are going to discuss two questions, okay, which may come in your exam also. Already it can come in your exams, in your subjective exams. So see this. First one is in 10.34 bar in the form of P by Q is. So what we have to do is that we have given here 10 by 10 point, see this 10 point, I'll change the size. We have here 10.34 bar, that is equals to nothing but 10.343434, and that keeps on going. 34 is being repeated over here. Okay, 34 is being repeated, isn't it? Now if I have 34 repeated, now I have to write in the form of p by q in a fractional form. Now what is this 343434? It's nothing but terminating but recurring, so I can write in the rational number form. So how will I write? Let's say I'll take a variable x. So that the value of x is this. X is equal to 10.34 bar. That is the value of x. Now, if I check, there are two digits repeating. The how many digits are repeating? Two digits are repeating. So what will I do? I will multiply by 100 on both sides. Multiply by 100 on both sides. Why? Because two digits are repeating, so I'm taking two zeros number. So I'll multiply by 100. So 100 into x will give me 100x. Now if I do 10.34 into 100, what will happen? These two digits 3 and 4 will go ahead, so it will become 1034. 1034.34 bar it will become, isn't it? Now, let's say this was my equation number. Let's say this is my equation number 1. This is my equation number 2. Now, if I subtract, we will do subtraction now. Subtract 2 from 1. Okay, now what will I get from here? Or 1 from 2. Okay, so what you can write here is, we will conclude from this that, I'll change the color. We will conclude from that. Now 100x LHS we will take same, so 100x minus x equals to what? 100x minus x, that is the LHS. Now RHS part is 1034.34 bar minus 10.34 bar. These two values we have. Alright. Now 100x minus x is nothing but 99x, and 1034 minus 1034.34 and 10.34 bars. So this 3434 gets cancelled. So 1034 minus 10 gives me 1024. And as the final answer, what will I get is, I will get that the value of x is equals to 1024 by 99. So that is my final answer. I write it in the P by Q form in this way. Okay. So that way we are going to do it. Okay. Now, let's move towards the next question. Now you can see here, I'll show you the solution. This was my solution. This is written solution. If you see, the answer is just the same. Alright. Now we have to do next question, that is how root 5 can be represented on a number line. How can I represent root 5? Now students, again we have few steps here. So root 5. Can I write root 5 in the form of root 4 plus 1? I can write in that form. Now 4 can be written as root 2 square plus 1. Okay, root 2 square plus 1. So this is nothing but 2 plus 1, right? So let's draw a number line. Okay, let's draw a number line. I'll draw one number line over here. Okay, let's say this is my number line OA. OA, it is of 2 units. Okay, it's of 2 units. You can see here, like this I'm going to do it. So what I'll do is that, okay, I'll not take it off for this way. Let's say, give me 1 minute. We will say that we have a line segment PQ. Okay, we have a line segment PQ, or see this. As per the figure you can see here, we will draw one line. Okay, any line we can draw, take it any name, doesn't matter, we are just doing it for the sake of the line. So let's say I'm drawing line M. Okay, now here are my negative numbers, -2, -1, 0, 1 and 2 and 3. Keep something like that. Now I have 1 and 2 here. Okay, so what I'm going to do is that I'm going to use them. So I'm going to say that this is my OA. OA of 2 units. So this is my OA, one line segment. Okay. After that I'll take AB. This is my one line segment. I'll draw a line here. This is one line segment of 2 units. Now, after that what will I do is I'll draw AB. AB, which is of 1 unit of the same measurement, or this much. So I'll draw one more line here as AB. Okay. Now, what I have to do is that this is 1 unit. So if I use the Pythagoras theorem, hypotenuse square is equals to what? Base square into perpendicular square. So hypotenuse is this OB, this OB. So OB square is equals to OA square plus AB square, isn't it? Now, what will I do? OB square equals to OA square, that is 2 square 4, plus AB square, that is 1 square, that is 1. Now OB square is 4 plus 1, so OB is equals to root 5. 4 plus 1 is 5, so I'll take the square here, so it will become a root. So root 5. So this length is root 5. Now you will have to take a compass, you will keep it at A, keep this at this, and you will cut it here. So this is my root 5 on the number line. Here you can see, these are the steps you will write in your exam. Okay, and this is how you will draw your figure. Okay, you have to cut an arc. Now students, let's move towards the next part, which is a Menti quiz. Alright, so let's do a Menti quiz now. So you can do, ma'am, rationalization. Abhishek Yadav, you want to should I explain you rationalization again? Okay, I'll do that. Give me 1 moment. Okay, you want me to explain you rationalization? This part, should I explain you again? Abhishek, please confirm in the chat box. If it is, I'll explain you now. Is it so? Um Okay, I guess you wanted to be explained. Fine. So see, rationalization is nothing but Abhishek, what you have to do is that whenever I have any real number, for example 1, by, it is written in the form of root a plus b. Now this root a plus b is what? It is an irrational number, right? It is irrational. Now I have to convert this irrational number into rational number. So to convert it from irrational to rational, what I have to do is that I have to do rationalization. So for example, I'll explain with the example. I have 1 by root 7. Okay. Now root 7, I have to convert it into rational number. So what will I do? I have to multiply by the same number. That is root 7 by root 7. Now what will I get? Root 7 into 1 is nothing but root 7 only. And divided by root 7 into root 7. So here if I solve root 7 into root 7 is nothing but what? It is nothing but root gets cancelled out and we will get here 7. So root 7 by 7. Now if you check the denominator, it is a rational number. It's a rational number, isn't it? So it's a rational number. So yes. Okay. Uh, hello, Lata. Hello, Lata. How are you? Welcome to Tuition Masters. So as I said, so this becomes my rational number. Okay. Now, if I have like in the form of root a plus b, that way, है ना? So how will I do that? See, if I have 2 by root 7 plus 1. This is my number. Now I have to rationalize it. So whenever you have in this form, root a plus or minus b. Okay, very good, Lata. Thank you for saying. So root 7 plus 1. What will I get here? I have to multiply by what? The same number? No. I will change the sign. I will change the sign and make it as root 7 minus 1 divided by root 7 minus 1. Now, if you check here, do I get two things? Do I get root 7 plus 1? Root 7 minus 1. Is it in the form of a plus b multiplied by a minus b? It is in that form, right? So what is this a plus b a minus b? That is nothing but a square minus b square. So I will do a square minus b square. What is my a is root 7. So root 7 square equals to, sorry, not equals to, subtracted from, we will do subtracted from b square, that is 1 square, right? I'll do it from 1 square. Now what will I get here is root 7 square is nothing but 7 and minus 1, that gives me 6. Super easy. So what do I get? 2 into root 7 minus 1. So 2 into 2 we can do. So root 7 minus 2 by 6 is my rationalized form. Okay, is it clear to you, Abhishek? You asked it. Everyone, is it clear? Everyone, rationalization is clear. How do we rationalize? If you have any operation like root a minus b or root a plus b, that way, so you always have to flip the sign and write it. Okay, that is what rationalization is. Super easy. So uh, we did laws of exponents and we even discussed these two questions. How do we write 10.34 bar in form of p by q, and how do we write root 5 on the number line. So now students, it's time for our Menti quiz. So let's go to menti.com, then we'll discuss polynomials. So you have to go on menti.com, enter the code 21161305. I will send you the link as well. So we are doing the number system quiz. We completed with the theory part. So let's do the number system quiz. Now, where is my going on live stream? Yes, here. So see, live streaming going on. I'm going to paste it in the chat box here. I've pasted the link. What you all can do is that you all can open that link and enter with your name. Okay, you can enter the Menti quiz with your name, and then we will start the quiz then. Okay, so yes, I'll go back. mm, Number system quiz. Okay, so yes, once you all are joined, then we will start with the session. Okay. I mean, start with the quiz. So you all can tell me when you all have joined. Okay, we will start. 1 minute. I'll just go ahead. Okay, once you all get join, I can be able to see you here. All right. Okay, so you can join first. You can enter the code conmenti.com. Enter the code 21161305. 21161305. You can enter the code and you can join to the Menti quiz. All right. So once you have joined, you can let me know. We will start with the quiz. All right. Okay, I can see one of you have joined here. One of you have joined. I can see it. Everyone else also joined. I'm waiting. Okay. Yes. Okay, Abhishek. Okay, I'm waiting. All right. So, one moment. Okay, I can see one of you here. Waiting for others also. Remember the code. It's 21161305. That is the code. You can join from there. I'm waiting for all of you. So, let's move ahead. You all can join from here. Yes, the code is 21161305. Okay, 21161305. All right. Okay. So I'll be starting. I'll be starting it now. Okay. So the first quiz is here. We are starting. So question number 1 says that minus 2 minus root 3 multiplied by minus 2 plus root 3. When we simplify this, what is the answer? Okay, is it a positive number and irrational? Is it positive rational? Is it negative rational? Or it is what? Which number? You have to tell me that. Alright, so let's see, you can solve it. It's super easy question. Okay, everyone has voted. Let's see. Okay, so we have positive and rational as the correct answer. Very good. That's the correct answer. Positive and rational. I'll solve it later if you all wanted. Okay. Now, let's move to the next question. Question number 2. So, question number 2 is insert a rational number between 0.15 and 0.16. So you just have to look at the correct number, I mean the number from the options which is suitable, and then you will have to give the answer to it. Okay. So yes, we have 0.14, we have 0.1459, then we have 0.1601, 0.158, and that way. So yes, I can see everyone has voted. So okay, the correct answer is 0.158. 158. So it's coming after 0.15 and before the before 0.16. So that's the correct answer. Good job. next question is enter. Okay. Next question on your screen. Express 0.777, I mean 0.7 bar in the form of p by q, where p and q are integers and q is not equals to 0. Okay, so that is what your question is. You have to write it in the form of a rational number. Okay, you have to write it in the form of a rational number. So yes, you can write it down. What will it be? Think about it. You have to solve it. We have to put the value of x, this is x, then what is the other way, that way. Okay, so I can see everyone has answered, and the correct answer, very good, all of you gave the correct answer, that is 7 by 9. All right, next question. Question number 5, I mean question number 4 is here. Decimal expansion of root 2. Root 2, what is the decimal expansion? Is it a finite decimal, means it has finite digits? It is 1.41421, non-terminating recurring or non-terminating non-recurring? Which of it is correct? You have to check it and tell. So which one is correct? Okay, I can see everyone answered here. And the correct is non-terminating, non-recurring. Why? Because 0.4142 and it keeps on going on. That's not the exact one. It's a non-terminating, non-recurring. It keeps on going without any specific pattern. Alright. The last question is here. So last question is, find a rational number between 2 by 5 and 3 by 4. So what you have to do is basically you have to find a number. You have to find a common denominator in them, and then it will be super easy. So you have to find a common denominator and insert the rational number. Okay. Enter a common denominator and put the rational number. So everyone has voted, and the correct answer is 13 by 2. 13 by 20, sorry. So 2 by 5 multiplied by 4 and 3 by 4 multiplied by 5. So denominator will be same, and then you will find your decimal. So let's see our leaderboard. And on the leaderboard we have Bell first, next we have Bill, and we have Rahul also. All right, very good everyone, congratulations. So very good, we have done with our Menti quiz number 1. So now we will come back to our streaming, right? We will come back. So quiz time done. These were all the questions, correct? So insert a rational number 0.77, then decimal expansion, and all of this. Shankar Kumar. Yes, hello Shankar. Hello, how are you? Welcome to the session. So yes, students, now we are moving towards our next part of the session. That is, we are moving towards polynomials. Now we will see about polynomials. If you have any doubts, again you can write it in the chat box. I am having a look at it. Now polynomials. When I talk about polynomials, what is the basic polynomial meaning of it? So any algebraic expression which has more than one term is called a polynomial. When there is more than one term, right? For example, 2x plus 3. It has two terms, 2x and 3. That is a polynomial. Then 7y minus 2y minus x. That is a polynomial. So whenever there is any algebraic expression which has more than one term, it's known as a polynomial. Now we have condition that it should be a positive integral power, means it should be the exponent, the power. If there is any power like 2x square minus 1, if there is any power, so that power should always be positive. It cannot be a negative power, it should be always positive. Now, what is polynomial in one variable? When I have any polynomial p of x, where x is the variable, so a0 plus a1x plus a2x square, and it keeps on going till an xn. So where a1, a2 till anth, what is that? They all are real numbers. They all are real numbers. Whereas n is the negative, non-negative integer, means the integer is positive. So that is called a polynomial in variable x. So there will always be one single variable and the degree is n. Now what are terms? In a polynomial, let's say if I have a polynomial 4x square plus 3x plus 2. So in this 4x, 4x square, 3x, 2, all of these are the expressions. Okay, in the expression, and they are known as terms of the polynomial. Now what is the zero of a polynomial? Zero is nothing but a polynomial which have all coefficients. Of coefficient 0 is called a zero polynomial. And the constant polynomial 0 is called the zero polynomial and degree is not defined. So whenever I say zero of a polynomial, for example, zero polynomial, that means that it is a constant polynomial. Okay, it will have a constant number. For example, 7. Now if I do x raised to 0, that becomes a zero polynomial. Now x raised to 0 is nothing but 7 into 1, that is nothing but 7. So that's a zero polynomial. Now what's an algebraic expression? Algebraic expression is nothing but a expression where there are operations, there are terms, there are variables, there are constant, there are power. All of them are terms, expressions, algebraic expressions. So 3x, 2x square plus 3, x cube plus 2x minus 4, all of these are the various types of algebraic expressions. Now, what is the degree of a polynomial? Degree of a polynomial is nothing but the highest power of the polynomial. For example, 4x cube plus 2x square plus 1. What is the highest power? 3. So, it is degree is 3. It is cubic, isn't it? In this one, 5x raised to 7 plus 4x raised to 6 plus 2x plus 9. Highest power is 7. Okay, so that is what my degree is. Now, what are the types of polynomials based on this degree? On terms also. So when I say monomial, monomial means there is only one term. When there is one term, mono, that means monomial. Binomial means when there are two terms like 2x plus 1, that is a binomial. Trinomial means there are three terms like 2x minus 3 plus 4y. When there are three terms, that becomes a trinomial. Now, based on power, this was based on the terms. Now, based on power, what I have linear polynomial. Linear polynomial means where the power is 1. Linear means 1, so power will be 1. That is linear polynomial. Quadratic means when their power is 2. For example, 2x square minus 3y. So here what is the highest power? 2. So this becomes a cubic. Sorry, quadratic. Now biquadratic, bi means double. So it will become 2 into 2, that is 4. So when I have 3x square minus 2y raised to 4 plus 1. So what is that? There is 3 or 2 and 4 both. But the highest is 4. So it is a biquadratic polynomial. And cubic means when the power is 3, for example, 3x cube minus 2y square. Highest power is 3, that is my cubic polynomial. Super easy. Now, how do I find zero of a polynomial? Whenever you have to find a zero of a polynomial, what you have to do is that you just have to equate. For example, 4x minus 3. You write it equals to 0. Just do that way. What will I get? 4x equals to, the minus 3 goes there, it will become plus 3. And x equals to 3 by 4. That means when I put this 3 by 4 in this equation, I will get 0 as the answer. So that is what my 0 of a polynomial is. Next is the remainder theorem. Remainder theorem is nothing but if I have any polynomial of a degree which is greater than or equal to 1. So that polynomial p of x is divided by linear polynomial x minus a and the remainder is pa. So whenever polynomial p of x is divided by x plus a is any real number, x is the variable. So remainder will be p into minus a. Similarly, we have this conclusions. If it's divided by ax minus b, the answer will be p by p multiplied b by a, and similarly it keeps on going. Factor theorem is what? Factor theorem is nothing but if x plus a. It is a factor of polynomial p of x if and only if p minus a should be 0. Means when I take the 0, x plus a. So the 0 of it, the 0 of x plus a is what? It is minus a, isn't it? Clear to everyone? So that when I put this here, so P of minus A should give me a 0. That is what factor theorem is. Factor theorem and remainder theorem clear to everyone. So polynomials again is a super easy chapter. Whenever I have a polynomial P of x, degree is greater than or equals to 1. A is any real number. So what we will have? These all conclusions we will have. And x minus a, where x is the variable, a is any real number, will be the factor of p of x. And if p into a, if I mean p of a, if I put value of a in it, give me 0, so that will become my factor. Okay, and if p of a, the 0 itself is 0, so what will happen? X minus a will be the factor of it. That is what factor theorem is. Super easy. I hope everyone, it's clear to everyone. You can write it in the chat box if it's clear or any doubts you have. Alright. Now, algebraic identities. There are few, not few, I'll say there are 9 algebraic identities in this chapter. So these all are identity. I won't say anything in it because it's super easy. You just have to always remember this. No derivation, nothing. Just remember all these identities. 9 identities are there. Okay. So let's go to the last Menti quiz of the day. So yes, you can go to menti.com, put the code 38926823. 38926823. So let's go to menti.com. I'll put the code over here. So we have our polynomials quiz number 2 now. I'll copy the link. 1 minute. Copied the link. Now going in our live stream, and here is the link. Okay, I've shared the link in the chat box. Make sure you just have to click on it, enter your name, and you will come to this live session. I mean the live quiz. So yes, you have to enter the code. Alright. So I'm waiting for all of you. Polynomials, just remember the identities and then remainder theorem, factor theorem, what a degree and everything. And then the chapter is super easy. Okay, you will be having time for doing the quiz, so you can take your own time and do it. Alright. So yes. Let's go. If everyone have joined, please let me know. Just put it joined in the chat box if you have joined the live quiz for our polynomials. Okay, so let's see. So yes, yeah, okay. The code is 3892 Okay, that is the quiz. I mean the code of it. So I'll go ahead. Okay, I can see one of you is connected over here. Waiting for all of you else also. Code is 3892 Alright. Okay. I can see one of you also joined. Okay. So I will start the quiz. The link is posted, right? Okay. So you have to, there are 4 questions. I've given sufficient time for all of them. So you have to read the question, you can solve it, and then you can do the quiz. Okay. Alright. Oh, give me 1 minute. I guess my system hanged. Give me 1 moment. I'll just refresh the stream. Okay, yes, here. 3892. Okay, I'll be starting the quiz now. Okay, so I'm starting the quiz now. Again, I'll say the code. It's 3892 6823. That is the code, and I'm starting here the countdown. So yes, your first question is on the screen. Is x minus 4 a factor of the given expression? There's an expression given. You have to check if minus is x minus 4 a factor of it or not. Means you have to substitute the value using factor theorem, and then you will be able to find. If you're getting a 0, that means it is, and if you're not getting a 0, that means it is not a factor. Alright, if you're getting any remainder, that means that it is not there. So I guess everyone has voted. So the correct answer is no, and very good. Both of you have given the correct answers. Let's move towards the next part. Okay. Next question is here. If p of x is equals to x square minus 2 root 2 x plus 1, then p into 2 root 2, okay, is equals to what? So you have the time. Okay, you have the time to solve it, so you can just solve it and then click on the suitable option. So I see everyone have correct, so I'll just click on enter, and we have two answers here, 4 root 3. Alright, so see here. So the correct answer is 4 root 3. Alright, so I'll go ahead here. Alright, correct answer. Now, uh, question number 2. Question number 2 says that, here is the question number 2. I mean, question number, 1 minute. Question number 2 is done, right? Yeah. Alright, here. Question number 3, second last question. So question number 3 is degree of the zero polynomial is. If I have a zero polynomial, what will be the degree of it? It can be 0, it can be 1, it can be natural number, or none of these. Which of them will be a 0? So you have to find out that. Which of them will be a 0? So everyone has voted, and the correct answer is none of these, because degree of a zero polynomial is not defined. The power, the exponent is not defined in a zero polynomial. And moving towards the last question of the day. The last question is value of 249 square minus 248 square is. You have to use the identity a square minus b square. Okay, you have to use a square minus b square, and you will get your answer to it. Just use a square minus b square, that is a plus b and a minus b. Super easy. So let's see. So yes, we have correct answer as 497. So you have to just do addition, subtraction, multiply, and that will give the correct answer. So here is the reader board. We have Manish first, and second is Ribbit. Okay, fine, great. All right, so we have completed with our quizzes. Hello Krishna. Hello, how are you? So we have completed with this first quiz. I mean the second quiz, last quiz of the day. So let's come back to our PowerPoint. So yes, these were the questions, factors. Then you just have to put the values. Already, if you have any doubts, you can write in the chat box. And here is the homework question. Okay, here is the homework question of the day. So it is the you have to factorize this a problem, a square minus 2a plus 3b whole square. This is your expression. You have to factorize it, and you have to give me the answer of this in the comment section, not in the live stream. In the comment section, you have to give me the answer to this. So thank you so much, students, for watching today's video. Don't forget to like this video if you didn't do till now. Share it with your friends, and make sure you all join the next time with your friends, and even comment down the homework. Don't forget to subscribe to the channel if you didn't do it now, and hit on the bell icon also to get regular notifications. I'll be seeing you in the next video. Till then, everyone, take care and goodbye. Thank you.